Hello, and welcome back to Quantitative Reasoning Online, Lesson 16a, Education Pays. Okay, we did a tutorial not too long ago, and let's show you here to see the questions. So let's go check them out. There's 3 of them. So question 1 is, alrighty. See, we have a graph. Shows data on some home-based workers, again, age distribution of at-home workers. You just got below estimated percentage of at-home workers part A through E. A, B, C, D, E, 5 parts. So let's see, age 15 to 24. Here we go. Looks like about 4%. Alrighty. We're seeing better. 25 to 44. Okay, here's 25 to 44. Now here's a 15 and 25. That totals to 40. Same ending, 44, but 15 to 44. And this one was 4. So let's add 4 to the previous problem, add the 2 previous ones together, 44. And 45 and older. Well, let's see. This should all add to 100%. I got 40 over here. So this should be 60 over here. Let's find out. This was like 27, 20, and another 7. Oh, make that 8. So how does that add up? That's 20. That's 20, 40. 40 and 15. That's only 55%. Oh, duh. Getting too smart for my own good. This wasn't 40, it was 44%, which means this should be 56%. And eyeballing it, we got 55%. So yeah, 56. Sometimes I'm trying to be too smart for my own good. Then 45 to 64. 45 to 64. Chart these 2 numbers. And that looks to be about 47%. Now they're saying 47 is close to 48 and 44. Remember with this guy. Yep. Go back. Okay. 3 parts, A, B, C totals. So most people who work at home, at-home workers, are younger than 45 years old. So part A, we're looking to see if this number is greater than 50%. And let's look at 7, 11, 20. So 7 and 11 is 18. 18 and 20 is 38%. So I would say false. Sum of the first three bars is less than 50%. There are more people between 55 and 64 who work at home than people between 15 and 24. Double check. 55 to 64 more than there are 15 to 24. And just looking at the graphs, you can see this guy is much taller. So, oh yeah. True, the height of the bar, 55, 64, height of the bar is greater than the height of the bar for 15 and 24. As people get older, they tend to stop working at home. False, the graph represents the same people over different ages of their life. The bar gets taller over time. True, the graph represents people who are in different age categories, not the same people over different ages of their lives. Okay. Remember from the tutorial, we had something very similar to this one, and we based it on this guy here. That's false, because the graph represents people who are in different age categories, not the same people over different ages of their lives. Like this is a snapshot of a snapshot of workers today. Oh, one more. Yeah. Let's see, about 11% of all people between 25 and 34 years old. 11% of all people between 25 and 34 years old work at home. Okay, now, yes, the graph does represent 11%, but it's 11% of people who are at-home workers. Now, what they're saying here is 11% of all people between 25 and 34 work at home. What is 11%? What the graph says is 11% of workers who work at home are between 25 and 34 years old. Which would be B. It's false because the graph represents percentage of workers who work at home, not percentage of all Americans. What a bum. Okay, now we're going to do some relative stuff and absolute differences. 1 year, 3.8% of workers identify themselves as home worker. A few years later, 2.4% of workers identify themselves as home workers. So let's see. So year 1, 3. I probably shouldn't put it there because there's going to be more stuff coming up. So year 1, 3.8%. A couple years later, let's go with year 4, we're at 2.4%. So the absolute change, okay, so the absolute change, it's going to be where we started, where we ended up, minus where we were, which is a minus 0. Okay, 3.8 minus 2.4 is 1.4, minus 1.4%. Okay, percentage out here, so we don't need a percentage sign. Okay, don't necessarily agree with that. Well, I guess we're discussing, yeah, being absolute change. Let's say look for the sign, which is true. Now, the relative change in percentage of workers who identify themselves as home workers is now let's give it a try. Absolute change over our starting point. So 1.4% over 2.4% times 100%. %58.33%. 2 decimal places. Okay. Oh, see my error? So this is going bigger. We start at 3.8%. So 1.4 over 3.8% should have been the numbers we used. So 36.84% change. Again, 3.8 to 2.4 is a change of 36.84%, absolutely. I personally think we should have a sign attached to it showing it got smaller, but there you go. There you have it. Remember how they're defining it. Absolute change is, they use the absolute value signs for absolute. Basically, new minus original, or new minus old. Or finish minus the start. Use one of the mnemonics to help you. Or absolute bigger minus smaller is what's going to happen. The kicker though, if you do it this way, if you do either this way, or this way, define your relative change. Dang nabbit. Find your relative change, you always divide it by the second number. If you're going to use this guy, you got to remember which one was your starting number. That's my only complaint with how they show it. And that is it for questions for lesson 16A, quantitative reasoning online, education pays. Which means go back into it and do them yourself, and then get ready to go in with Stephanie and do the workbook assignment for 16A. Then copy, load them up, and then do the practice assignment. And I'll see you next time for lesson 16B preview.